For question C, we have two questions. Let's first look at the first one. Explain how the estimates of betas obtained in GLM are different from the ones in GLMM. So this is my answer, just for information. So first, we should know that for GLM, we are using GE method to estimate the betas. But for the GLMM, we are using the MLE to estimate the betas. We use a different method, and that's why we are getting the different estimates for betas in these two models. So let's look at more details. So for GLMM, we should know that for this part, it's a distribution function for Yij given Bi. We should know that if we are not including this part, if we don't have, if we are not given Bi, the Yij and Yik are correlated. They are not independent. But if we given Bi, Yij and Yik are mutually independent, and that's why we can just times these functions together to get the joint probability functions for Yi. And we can treat this part as a multivariate distribution function for Yi. And the same story here, we have a distribution for Bi, and we have the PDF for Bi. And we know that the Yi and Bi are independent, and we have the distribution function for Yi given Bi and Bi. And we times them together to get the joint probability function for Yi and Bi. Once we have this function, we can use maximum likelihood estimation to get the betas, to get the estimations for betas and G. But in GLM we can't do that. We cannot use MLE. That is because, like I said, the Yij and Yik are correlated. We cannot have a multivariate distribution assumption for Yi in GLM. So in that way, we won't have these PDF. We won't have this joint PDF, so that we cannot use MLE. We can only use GE to get the estimations for betas and G. So in this way, we can explain why the betas are different. And I can also show you another way to understand this question. So like I said here, GLM is a marginal model and the GLMM is a conditional model. They are not the same for non-normal data. For normal data in the linear mixed effect model, we have the identical link function, which is G mu equals mu. So if we want to, so this is the conditional mean model. This is random effects. This is the main effect, and this is a conditional mean model. This is a marginal mean model. We can just easily calculate the expectations for both sides, for the left-hand side and the right-hand side of the equation. And for the left-hand side of the equation, this is equal to this. They are the same. And the details shown here, if we do the calculations of the expectations of this part, we will get this one. So we may know that actually the betas in the conditional mean models and in the marginal mean models, the betas have the same interpretation. We can interpret betas on population average level, but it's not the same story in GLI for non-normal data. So you can see here, we can still get this part by calculating the expectation for this part. But on the left-hand side of the equation, if we do the expectation for this g function, we won't get this. They are not the same. So that is why the the betas in GLM and GLMM have the different interpretations. So basically, we are modeling different things. For GLM, we are looking at the population level. For GLMM, we are looking for a given individual. So that's why we have different betas for GLM and GLMM. So like we just said, the main difference between the model in GLM and GLMM is the interpretations about the betas. Like I said here, the main purpose of GLM and GLMM are different. For a GLM model, we are modeling the association between population mean and covariates, and the target of the inference is about the population. But in GLMM, we are modeling the association between the conditional mean and the covariates. So, so it's quite easy to answer the last question. When should we use the model in A? When should we use GLM and when should we use GLMM? So if your purpose of study is to make the inference about the individuals, you can use GLMM. But if your purpose is to learn about the population, you can just use GLM. I hope this will help. That's all. Thank you.